The introduction of this experiment for the scope, the first one is that we use two different loads, that is 5 Newton and 10 Newton. The second one is distance between the ends RA and RB is 900 millimeters. The third scope is that we have 3 points, P1, P2, a fixed point, and P3. The objective of this experiment is to measure the bending moment of material when it is subjected to different loads at different distances.
Okay, next for theory. Bending moment is the reaction force which is happen when an external force is applied. The stresses and deflection induced in a beam and the bending loads vary along the beam length and height.
In this experiment, there would be two sets of calculation that is needed to be made. The first one is the experimental values, which is calculated by multiplying the net force exerted by the beam by the height of the spring balance from the beam itself. And for the second one, it is the theoretical values, which is determined by drawing a bending moment diagram, which is depicted here.
Okay, for the experimental setup for this experiment, as we know that in this experiment we got two parts, which is part 1 and part 2. So in this slide, I will explain about part 1. So part 1, as we can see in this picture, I already paste here. So we labeled three main apparatus that we use for this experiment, which is experimental beam, load, and also load hanger. So if you can see, in the between of P1 and P2, we got spring balance. And then for this experiment, we will arrange, or we will adjust P1 200 millimeter away from P2, as we know that P2 is fixed. And then P3 will be adjust 300 millimeter from P2. And then we will go to the next part, which is there will be a little bit different between part 1 and part 2. So next, part 2. So as we can see in this picture, there will be the same apparatus that we will use for the next experiment, the next part. But the difference is the distance between P2 and P3 is difference between part 1 and part 2, because in the part 1 we only adjust the distance between P2 and P3 is only 300, but for this experiment we adjust it to 400 millimeter, but the P1 is still the same, 200 millimeter. So this is the only difference between part 1 and part 2. So we will continue to methodology. So for first part, basically P1 will be is adjusted 200 millimeter away from P2, while P3 is adjusted 300 millimeter away from P2, which is P2 is fixed. So for first part, basically P1 will be is adjusted 200 millimeter away from P2, while P2, then spring balance is adjusted until the bubble move to the center, and then the initial reading for spring balance is recorded, and then spring balance is adjusted until the bubble move to the center, and then so 5 Newton is put at P1, and then the spring will be adjusted, and then we take the reading. After that, the step 1 until step 6 we repeat with 5 Newton, but we put at P2 and P3. After that, we repeat all the step, but with 10 Newton. So 5 Newton is put at P1, and then the spring will be adjusted, and then we take the reading. So for part 2, P1 is adjusted 200 millimeter away from P2, and then P3 is adjusted 400 millimeter away from P2. After that, we adjust the spring balance until the bubble go to the center, and next we read the initial reading and record in the table. So for part 2, P1 is adjusted. After that, we put 5 Newton at P2, and then for P1 and P3 is zero load. And then we adjust the spring balance and record the data and put in the table. After that, we put 5 Newton at P2, and then for P1 and after that, we repeat the experiment using 10 Newton. 10 Newton we put at P1, and then 5 Newton at P2, and then 10 Newton at the P3. And then we adjust the spring balance and record the data. After that, we repeat back the experiment, but for the other reading, which is 5 Newton at P1, 0 Newton at P2, 3 Newton at 10 Newton at P3, and record the data. So done for part 2.
Next result. When we didn't use any load, there is no net force, therefore there is no bending moment. And when we add 5 Newton, the net force at point 1 is 2, and the experimental bending moment is 300, and theoretical is 332. And P2, the net force is 6, and experimental bending moment value is 900, and theoretical is 999. At P3, the net force is 4, and the theoretical is 501, and the experimental is 600. And when we use 10 Newton, the net force at P1 is 6, and the experimental value is 900, and theoretical is 778. And when at P2, the net force is 14, and the bending moment experimental value is 2100, and theoretical is 2000. While at P3, the net force is 8, and experimental bending moment value is 1200, and theoretical is 1000. Next, part 2. When we didn't use any load, there is no net force, and when we add 5 Newton at point 2, the net force is 6, and bending moment for experimental is 900, and theoretical is 999. When we use 10 Newton at P1, and P2 is 5 Newton, and P3 is 10 Newton, the net force is 16, and experimental value is 2400, and theoretical is 2332. And for 5 Newton at P1, and point 2 is 0, and point 3 is 10 Newton, the net force is 6, and experimental bending moment is 900, and theoretical is 2001.
For this slide, for the first one is 5 Newton is at P1. So to find the RA and RB, so for the first one is to find RB, we use formula delta moment is equal to 0. So we got the RB is 0.55. After that, we use total force of Y is 0. So we got the RA is 40 per 9. After that, we got the experimental moment for this part is 300 millimeter, and then the theoretical is 332 Newton millimeter. After that, for the second picture, is show that the 10 Newton is at P1, while the others is 0 Newton, and P3 is also 0 Newton. So we also use that total moment of A is equal to 0, so we got the RB is 1.11, while for the RA we got 8.89 Newton. So the experimental moment we got 900 Newton millimeter, while theoretical is 778 Newton millimeter.
Next, when P2 is loaded with 5 Newton, by using the formula total moment is equal to 0 and total force is equal to 0, we get the RB and RA, which is RB 5.3 Newton and RA is 3.33 Newton. And the experimental moment is 900 Newton millimeter, and the theoretical is 999 Newton millimeter. Next, when P is loaded with 5 Newton, by using the formula moment is equal to 0 and force at Y is equal to 0, we get the RB is 5/3 Newton and Ra is 3.33 Newton. And the experimental moment is 900 millimeter and the theoretical is 999 Newton millimeter.
At point 3, for a 5 kilonewton load, we have obtained an experimental values of 600 Newton millimeters and a movement of 501 Newton millimeters for the theoretical values that we have calculated. On the other hand, for the 10 kilonewton load, we have obtained an experimental values of 1,200 Newton millimeters and 1,000 Newton millimeters for the theoretical calculation.
So as we can see at the left side of this slide, so it shows that the 5 Newton is at P2. So we just use the formula delta moment is equal to 0. And then we got the RB is 1.99 Newton. And then we use the total force of Y is 0. So we got the RA is 3.33. From this experiment, we got the moment is 900 Newton millimeter and then the theoretical moment is 999 Newton millimeter. At the right hand side, we got the picture that shows the P1 is 10 Newton, P2 is 5 Newton and then the P3 is 10 Newton. Also use the same formula, we got the RB is 10.56 Newton and then RA is 14.44 Newton. So from the experiment, the experimental moment is 2,400 Newton millimeter and the theoretical is 2,332 millimeter. That's all.
For the last part of the discussion, which is to plot the shear diagram and bending moment diagram when P1 is 5 Newton, P2 is 0, and P3 is 10 Newton. By using the summation of moment equals to 0, we will get RB, which is equals to 8.33 Newton. And with this value, we use the summation of forces in the vertical direction to get the value of Ra, which is 6.67 Newton. And then this is the diagram for shear force and bending moment. The experimental value is 900 Newton mm and the theoretical value is 1001 Newton mm.
The bending moment obtained from the experiment is mostly off from the theoretical values by 100 Newton millimeters. This may happen due to the large gradations on the spring balance, which allows a less precise reading to be taken. There is also other factors that was not taken account in the theoretical calculation, which was present during the experiment, such as the presence of air currents, the slight flex of the beam, as well as the movements of the load member.
For safety procedure, make sure the eye level is perpendicular to the scale of the roller when taking a reading. Make sure the spirit level is centered before taking reading from the spring. Check the masses of the weight to avoid using weight loss mass due to the wear and tear. For safety procedure, make sure the eye level is perpendicular to the scale of the roller when taking a reading. Make sure the spirit level is centered before taking reading from the spring. Check the masses of the weight to avoid using weight loss mass due to the wear and tear.
So, from the experiment, we have obtained the bending moment of the beam when different loads is applied, and we have found out that the bending moment increases as the load approaches point B, and has the lowest value nearest to the ends of the beam. While, for the second experiment, it is found out that the bending moment is highest when the configuration of the load is 10 newtons, 5 newtons, and 10 newtons at point 1, 2, and 3 respectively, which is determined to be 2,400 Newton millimeter. And there are some errors that contribute to the inaccuracy of the data obtained from the experiment, such as the position of ice not being perpendicular to the scale reading of the spring balance and the spirit level, and the load hangers moving around while adjusting the spring balance. To overcome these errors in the future, multiple readings of the scale reading of the spring balance should be taken. Moreover, it is beneficial to have the surface of the beam to be a little bit rougher to prevent the load hanger from slipping.
These are the list of references. The first one is the textbook, which is Mechanics of Materials. The second one is the laboratory manual. The third, the third, fourth, and fifth is their websites, which is to help us with the bending moment diagrams and understanding the beam analysis.